when you plug your phone charger into the wall, there is just this built-in expectation of infinite immediate power.
Right. You don't even think about it.
Exactly. You push the little metal prongs into the plastic outlet, the battery icon turns green, and you're good. It's this completely invisible, instantaneous process that we have all been conditioned to just take for granted.
Well, I mean, at least until a massive storm rolls through or, a transformer blows down the street and the whole grid goes dark.
Yeah, and in that split second, that magic wall socket is just a useless piece of plastic sitting in your drywall.
It really is a terrifying realization when it happens.
It is,
Yeah.
because you suddenly understand just how completely tethered we all are to this massive centralized aging system that we can't see, we can't control it, and honestly, it moves incredibly slowly when it actually needs to adapt.
It moves at a glacial pace, yeah.
So, welcome to another deep dive. Today, our mission is to explore a massive hidden infrastructure revolution that is happening all around you right now. We are looking at this high-stakes race to completely bypass that traditional power grid.
And it is a fascinating race.
It really is. And to get to the bottom of this, we are pulling from a truly wild stack of sources today. First up, we've got the expansive 2025 data report from Perrin.
Which is great because that tracks the entire U.S. electric vehicle fast charging network.
Right. And then we are also looking at some really deep financial and strategic analyses from S&P Global and TIKR.
Specifically mapping out Uber's massive new autonomous vehicle strategy, which we will get into.
Oh, we're definitely getting into that. We're also folding in some corporate press releases from a mobile energy company called Exos.
Yeah, that's XOS for those listening.
Yep, Exos. And to tie it all together, we are unpacking this fascinating internal guidance document from the Department of Defense.
Right, regarding their fiscal year 2026 Energy Resilience and Conservation Investment Program, or, well, they call it ERSIP for short.
Okay, let's unpack this. Because you look at this stack, and you have to ask, what do a rideshare app buying tens of thousands of cars, a nationwide boom in highway charging stations, and a United States Air Force base all have in common?
It sounds like the setup to a weird joke.
It does. But the short answer is that they are all rapidly converging to solve the exact same massive energy bottleneck.
Oh.
But, to really grasp how these mega fleets and the military are securing their power, we have to start with the reality on the ground.
Right, we have to look at the baseline first.
Exactly. We have to confront this narrative that has been dominating the news lately about a supposed EV slowdown.
Yeah, if you read the financial headlines over the last, I'd say the last year or so, the prevailing story is just that the electric vehicle market is collapsing.
That no one is buying them.
Exactly. Sales growth cooled off for a few quarters, and the media just kind of ran with it. But the Perrin 2025 data report completely shatters that narrative when you actually look at the physical infrastructure being built.
The concrete and steel.
Right. Despite all the rumors, 2025 was actually a record-breaking year for U.S. fast charging.
Yeah, and the scale of the build-out is what really caught my attention. Because we aren't talking about, plugging a car into a standard garage outlet overnight.
No, not at all.
The Perrin report shows over 18,000 new DC fast charging ports were deployed in 2025 alone.
Which is a huge number.
It's a 30% year-over-year increase. And the momentum is just accelerating. I mean, the fourth quarter of 2025 shattered all previous records with over 5,700 ports coming online in just those 3 months.
What's fascinating here is that the demand is perfectly matching this massive influx of new capacity.
Wait, really? Because you'd think with that many new chargers, they'd just be sitting empty.
Well, you'd think so, but the industry provided a record-breaking 141 million charging sessions in 2025.
Wow.
Yeah, which is also a 30% increase. So, like you said, if you suddenly dump 18,000 near heavy-duty chargers into the market, standard economics would suggest that the overall usage rates per machine would just plummet.
Right, because the market is suddenly flooded with supply.
Exactly. But that didn't happen. The national utilization rate remained incredibly steady at around 16.4% throughout the entire year.
Okay, let's translate that 16.4% metric for you listening, because, to a layperson, hearing that a machine is only actively charging a car 16% of the time sounds like a terrible business model.
It does sound pretty low.
Right. Why wouldn't they want it running close to 100%?
Well, it comes down to the physics and the logistics of moving physical cars through a physical space.
Okay.
Like, a gas pump takes maybe 3 minutes, But a DC fast charge takes 20 to 30 minutes. So if the utilization rate of a charging station creeps up to, say, 30 or 40%, you don't just have busy chargers.
What do you have?
You have a line of cars backing up into the street. You have furious customers waiting an hour just to plug in.
Oh, I see. That makes sense.
Yeah, in the fast charging industry, 16.4% utilization is actually the operational sweet spot.
So it means they're making money, but people aren't waiting.
Precisely. It means the station is generating healthy revenue, but there is still an open port when a driver actually pulls up. It indicates that the new capacity being built is being actively and efficiently absorbed by new EV drivers hitting the road.
That's incredible. And, the players building this infrastructure are shifting too.
Very much so.
Because historically, Tesla has been the undisputed heavyweight champion of the charging world. And they had a huge year. They deployed nearly 6,800 supercharger ports.
Right.
But their overall market share of new deployments dropped to 37.6%.
Which is wild when you think about their historical dominance.
Exactly. It's because over 120 other network operators are just flooding the U.S. market right now.
Yeah.
And they're totally changing their playbook.
Yeah, they are no longer just installing, two lonely chargers behind a big box store somewhere.
Right. The average number of ports per station for non-Tesla networks jumped from 3.6 to 4.5 in just a year.
They are scaling up and they are pushing drastically more power. The Perrin report notes that 51% of all new ports deployed in the fourth quarter were 250 kilowatts or higher.
Which is a massive amount of juice.
Oh, pushing 250 kilowatts of electricity is a serious engineering feat. You are dealing with so much thermal output that the charging cables literally have to be liquid cooled from the inside just to prevent them from melting.
That is insane. So we are really moving out of the era of the slow trickle charge.
Completely. We're moving into a reality where you can add hundreds of miles of range in the time it takes to grab a coffee. And what is most telling is that the private sector is driving this almost entirely on its own.
Which completely defies another popular narrative we hear all the time.
The government funding narrative.
Yes, we hear so much about the government's NEV program, the billions in federal funding for the national electric vehicle infrastructure.
Right.
Yet, according to Perrin, even though NEV finally hit its stride and opened 99 stations in 2025, that still only represented 3% of all new ports for the year.
3%. That's it.
This boom is practically all private capital. But let me push back on the economics of this for a second.
Sure. Go ahead.
If you have over 120 companies fighting for market share and deploying billions of dollars of hardware, isn't this just a race to the bottom?
How do you mean?
Well, I'm thinking about the early days of cell phone tower expansion. Telecommunications companies were throwing up towers everywhere, and cell phone plans just got cheaper and cheaper as they tried to undercut each other to win customers.
Oh, I see.
So are these EV charging networks just bleeding cash in this massive price war?
The cell phone tower analogy makes logical sense, but the on-the-ground data shows a completely different dynamic. Pricing remained remarkably stable throughout 2025.
Really? No price cuts?
Nope. Across the vast majority of states, the average price hovered really tightly between 45 cents and 53 cents per kilowatt hour.
Huh. Why aren't they undercutting each other?
Because we are not seeing a race to the bottom on price. These companies have realized a fundamental truth about EV drivers. Nobody is going to drive 10 minutes out of their way to save 2 cents on a kilowatt hour.
That is a very good point. Convenience is king.
Exactly. The competition has shifted entirely away from price and into hardware execution. They are competing on reliability and uptime.
Because there's nothing worse than pulling up to a broken charger.
Precisely. If a customer pulls up and the screen is blank or, the credit card reader is broken, they will never use that brand again. You win the market by actually delivering the electrons when promised.
Okay, so we have this massive, privately funded, high-speed charging network expanding at 30% a year.
Right.
But even that massive grid expansion isn't fast enough for the new whales of the transportation world.
The robotaxis.
The robotaxis. I mean, if you think highway chargers are busy now, imagine what happens when a single company dumps tens of thousands of vehicles onto the road that literally never stop driving.
And that brings us to our S&P Global and TIKR reports regarding Uber.
Yes, because Uber is no longer just a software app living on your phone.
Not at all. Uber is undergoing a structural metamorphosis right now. For over a decade, their entire business model was built on avoiding physical assets.
Right, they didn't want to own cars.
Exactly. They were just a software distribution layer connecting a rider with a human driver who brought their own car to the transaction. But the S&P Global Analysis details how Uber is firmly entering what they call Phase 3 of their autonomous vehicle strategy.
And phase 3 is a big departure.
Huge. It's a hybrid model where Uber is suddenly stepping up and actually buying the physical vehicle.
Yeah, let's break that down, because phase I was their advanced technologies group, where they tried to engineer their own self-driving cars from scratch.
Which burned through billions of
It was
dollars.
a total disaster. Then phase 2 was partnering with companies like Waymo to just host autonomous software on the Uber app.
Letting someone else handle the hardware.
Exactly. But phase 3 involves these massive procurement deals. Uber is investing $300 million into Lucid Group to buy at least 20,000 autonomous gravity SUVs.
And that's just the start.
Yeah. They have another deal with Rivian for 10,000 R2 SUVs, which could scale up to 40,000 vehicles.
It's staggering.
Their stated goal is to have a global autonomous fleet of 100,000 vehicles by 2027. We're talking launches in cities like Hong Kong, Zurich, Tokyo, and Los Angeles.
And the thing is, they have the capital to do it. The TIK financial report shows Uber generated $52 billion in revenue in fiscal year 2025.
So the cash flow is definitely there.
The cash flow is there, but more importantly, the demand is there.
Yeah.
Uber's CEO explicitly stated that autonomous vehicle trips on the Uber network already run at a 30% higher utilization rate than standalone platforms.
Wow, 30% higher.
Yeah, they have the network density to actually keep these cars moving constantly.
See, I was looking at those financials, and I just couldn't wrap my head around the capital expenditure at first. Like, why would Uber abandon their highly profitable asset-light model to buy 100,000 expensive electric SUVs?
Right. It seems counterintuitive.
But the answer lies in the operational economics of a robotaxi. Think about it. A human driver absorbs all the inefficiencies of the electric grid.
Oh, that's true.
When a human Uber driver finishes their shift, they go home, they park in their garage, and they trickle charge overnight on their own dime.
But an autonomous Rivian doesn't have a garage.
It doesn't sleep. To make the billions invested in these robots worthwhile, they have to run almost 24 hours a day, 7 days a week.
And that is the critical pivot, because if an autonomous vehicle has to drive, say, 10 miles out of its way to find a public charging station and then wait 40 minutes for a spot to open up,
That's a lot of wasted time.
it accumulates what the logistics industry calls deadhead time. That is time the vehicle is on the road, it's consuming battery power, it's degrading its tires, but it is not generating a single cent of revenue.
Just burning cash.
Exactly. Deadhead miles absolutely destroy the unit economics of a robotaxi fleet. So to solve this, Uber must eliminate the friction of public charging.
They need their own supply.
They have to completely control their own infrastructure, which is why they earmarked over $100 million specifically for dedicated charging hubs for these fleets.
You know, it reminds me of the 19th century railroad barons.
No, how so?
Well, at first, maybe you just want to sell tickets and run a train schedule, right?
Right.
But eventually, to guarantee that schedule and control your operational costs, you can't just rely on other people's infrastructure.
Right.
You have to lay down your own steel tracks, and you have to build your own coal stations along the route. Uber is basically realizing that to control the autonomous future, they have to build their own digital coal stations.
The railroad analogy is perfect, but it highlights a physical reality that Uber cannot simply buy its way out of.
What do you mean?
Well, building $100 million worth of permanent charging hubs is not just a software update. To power a depot of, say, 100 fast-charging Rivians simultaneously, that requires megawatts of electricity.
Which you can't just plug into a wall.
Exactly. You have to petition the local utility company to upgrade the regional substation. You have to run new high-voltage lines. You have to dig trenches through concrete parking lots.
How's that bureaucracy?
And you have to secure municipal building permits. That process takes 2 to 3 years in a major city like Los Angeles.
2 to 3 years.
Easily. And Uber wants 100,000 cars on the road by 2027. They literally cannot afford to wait for the local utility grid to catch up.
Okay, so Uber hits this massive brick wall of utility delays.
Yeah.
And that sheer desperation to bypass the public grid is what's driving an entirely new market for mobile chargers.
Which brings us to EXO.
Exactly, bringing us to the press releases from Exos. Because they have engineered a literal physical workaround to this bottleneck. They call it the Charger Hub.
Yeah, the Exos Charger Hub is a fully integrated mobile DC fast charging unit.
Explain what that looks like.
Visually, imagine a large, heavy-duty commercial trailer. It houses up to 630 kilowatt hours of battery energy storage, and it is specifically designed to be towed by a standard heavy-duty pickup truck.
Okay, let's put 630 kilowatt hours into human terms.
Good idea.
That is roughly the equivalent of fully charging 8 to 10 standard long-range electric SUVs from 0 to 100%, completely off the grid, just sitting in a random vacant lot.
Right.
And the genius of this product is what it does not require. Because it is technically a mobile trailer, it requires zero utility grid upgrades.
None.
It requires zero trenching into the concrete, and it requires no permanent building permits.
It's a massive loophole.
It really is. A fleet operator can lease a vacant parking lot on a Tuesday, tow 3 of these hubs in on a Wednesday, and instantly have a high-capacity charging depot operational by Thursday morning.
And when the hubs run low on energy, the operator has options.
How do they refill them?
Well, they can either trickle charge the hub from a low-voltage existing connection on the property, or they can simply hitch the depleted trailer to a pickup truck, tow it back to an industrial center with cheap, massive grid access to refill it.
And just swap it out with a fresh one.
Exactly. Just swap it out with a fully charged hub. It is a completely modular energy system. And Exos recently secured a $3 million follow-on order for 12 of these charger hubs from a client they describe as a leading autonomous fleet operator.
I wonder who that could be.
Right. To power operations across North America and Europe.
The scale of this transition is staggering to me. The data shows the mobile energy storage market is projected to skyrocket from $58 billion in 2025 to $156 billion by 2032.
It's exponential growth.
We are literally watching the infrastructure of the future untether itself from the wall socket. We're moving from a world where you have to bring your vehicle to the power to a world where companies just bring the power to the vehicle.
It reverses the whole model.
Here's where it gets really interesting. If a commercial robotaxi fleet needs mobile, off-grid power to ensure constant 24/7 uptime just for the sake of corporate profit,
Yeah.
who else views constant uptime as an absolute necessity but for the sake of life and death?
The military.
The military.
Yeah, Exos is not just pitching this to Silicon Valley. They were recently selected as one of only 17 finalists to demonstrate their mobile charger hub live to the Air Force Global Strike Command down in Louisiana.
So the military is actively scouting this exact technology.
Actively scouting it, yes.
Which brings us to our final source today, and perhaps the most complex one. That internal fiscal year 2026 guidance document from the Department of Defense regarding their Energy Resilience and Conservation Investment Program.
The ERCP document.
Right. I was reading through this and, I was expecting standard military logistics, but it fundamentally redefines how the Pentagon views the future of power.
It's a huge shift in their doctrine.
Just looking strictly at their internal strategy metrics, as stated in the documents, the DoD explicitly states a preference for projects that increase energy resilience while simultaneously reducing greenhouse gas emissions and addressing the impacts of climate change.
Which is referencing Executive Order 14,008.
Exactly. We're just looking at their stated guidelines here, and the military views climate impact and base survival as intertwined metrics.
Yeah, but the core driver dictating every dollar spent in this program is a concept called mission assurance.
Mission assurance.
Right. The document references a specific statute, 10 U.S.C. Section 2920. This law legally requires the military to maintain their critical missions with a minimum energy availability of 99.9% per fiscal year.
Okay, let's do the math on 99.9% uptime.
Is barely any downtime.
Right, over the course of a 365-day year, that means a critical military facility can only afford to be without power for about 8.5 hours total for the entire year.
Which is
You cannot achieve that level of reliability if you are dependent on the civilian power grid, which we all know is increasingly vulnerable to extreme weather and cyber attacks.
No, achieving that 99.9% mandate requires a massive shift in infrastructure philosophy. The ERCP guidance highlights a transition away from simple energy conservation.
Which used to just mean, what, better light bulbs?
Exactly. Historically, that meant just installing more efficient HVAC systems or LED lighting. But now they are moving toward true energy resilience.
What does a resilient base actually look like?
A resilient base must be able to island itself.
Island itself.
Yeah. The DoD is prioritizing the construction of microgrids, which are localized power grids that can completely disconnect from the traditional grid and operate autonomously.
So they're building their own power plants.
Pretty much. They are heavily investing in massive battery energy storage and on-site baseload power generation. We're talking advanced geothermal plants and even small modular nuclear reactors.
Wow. But because it is the military, securing the funding to build these microgrids requires navigating just a labyrinth of bureaucracy.
Oh, the paperwork must be endless.
The documentation required for an ERCP project is intense. Every proposed project must include a life cycle cost analysis, or LCCA, and a detailed measurement and verification plan.
Right, standard government acronyms.
But the metric that really stood out to me was for projects categorized strictly under energy conservation. They must prove a savings to investment ratio, or SIR, of at least 1.25 to 1.
Yeah, that savings to investment ratio is a strict financial gatekeeper.
What does it mean in practice?
It means that for every $10 million the military spends on an energy project today, that project must mathematically guarantee $12.5 million in tangible savings over its operational lifespan.
So it actually has to turn a profit, in a way.
Essentially, yes. But financial savings are secondary to security. The guidance places a massive emphasis on cybersecurity under a mandate called UFC 4-01-06.
Okay, wait, I have to ask. How does a cyber attack actually take down a microgrid? I assume hackers aren't physically blowing up the batteries remotely.
Well, no, they don't need to touch the batteries. They attack the software routing the power.
Ah,
Modern microgrids are run by Facility-Related Control Systems, or FRCS. These are digital networks that read the energy demand and tell the batteries when to discharge.
okay, so if you hack that,
If a hostile state actor hacks into that control system, they can instruct the batteries to discharge all their energy into the ground, or even worse, overcharge the system until it physically catches fire.
oh wow, that's terrifying.
Yeah. So the UFC 4010-06 mandate requires these control systems to be heavily hardened, often physically air-gapped from the wider internet, to ensure that even if the civilian grid is compromised, the military microgrid remains impregnable.
So what does this all mean? We're looking at two wildly different worlds here.
Very different.
On one side, you have Silicon Valley executives trying to launch luxury electric robo-taxis in Los Angeles to appease shareholders. And on the other side, you have Pentagon generals managing global strike commands and nuclear bombers in Louisiana to ensure national defense.
Right.
Are they actually building the exact same infrastructure?
If we connect this to the bigger picture, the answer is a resounding yes.
It's really the exact same thing.
It is. Whether the ultimate goal is to maximize corporate profits by preventing a Rivian robotaxi from experiencing deadhead miles, or to ensure a critical Air Force base can maintain its 99.9% uptime during a targeted cyber attack on the civilian grid, the mechanical solution is identical.
They both need to cut the cord.
Exactly. The future of high-stakes infrastructure relies on untethering from the traditional centralized power grid. Both the commercial sector and the defense sector recognize that the legacy grid is a liability.
It's too slow and too vulnerable.
It is, and both sectors are willing to pay massive multi-million-dollar upfront costs to achieve total energy independence through localized microgrids, on-site generation, and mobile battery storage like that Exos charger hub.
It is a profound shift in how society will operate. I mean, we started this deep dive looking at a 30% boom in standard EV fast charging stations across the country, which proved that everyday drivers are actively demanding more power, and private companies are happily building the hardware to supply it.
Right, the consumer side is booming.
But that everyday consumer demand is just the tip of the iceberg.
Yeah.
Behind the scenes, that exact same need for massive, reliable power is fueling the rise of 100,000 vehicle autonomous robotaxi fleets.
Fleets that never sleep.
And because those fleets cannot wait years for traditional grid upgrades, they are single-handedly driving the creation of a $156 billion market for mobile off-grid battery hubs.
A total technological workaround.
Exactly, a workaround that is proving so incredibly effective and so remarkably resilient that the United States military is now actively adopting it for national security and base survival.
It illustrates perfectly how commercial desperation, driven by a need for efficiency and profit, can rapidly mature a technology to the point where it actually becomes a critical asset for national defense.
It really does.
But, as we watch these mega fleets and military bases secure their own independent power, it raises an important question for all of you listening.
What's that?
Well, think back to that wall socket we talked about at the very beginning. If the most advanced, cash-rich commercial companies in the world and the most powerful, highly resourced military on the planet are both looking at the data and deciding that the traditional centralized power grid is too slow, too vulnerable, and too restrictive for their needs. What does that mean for the rest of us who are still completely reliant on it to power our daily lives?
That is a very sobering thought to end on. Thank you so much for joining us on this deep dive. We will catch you next time.